Alright, so we're going to go through the review as is. So if you missed anything in class, you can pick it up here. Problem number 1 says to find one positive and one negative coterminal angle of 312. Well, to find coterminal angles, you got to go all the way around the circle. So that's 672 degrees when I go to the positive. And of course, we also want to subtract 360, which gives us negative 48. Problem number 2. We have this right triangle, and it's not marked as a right triangle on C, but it should have been. And we got 724. So the first thing we have to do is we have to find what the hypotenuse is so we can find the 6 trig functions. So when I do this, I get 625 equals c squared. Square root, c equals 25. And angle A is over here, which means when we go through this, 25 is the hypotenuse, 24 is the opposite of A, which leaves 7 to be the adjacent. So when we go through this, we're going to have the sine of angle A, the cosine of angle A, and the tangent of angle A. The sine is equal to the opposite over the hypotenuse. The opposite is 24. The hypotenuse is 25. For the cosine, we have the adjacent over the hypotenuse, which is 7 over 25. And the tangent, we have the opposite over the adjacent, which is 24 over 7. Since we need all 6, the other 3 are simply the reciprocal of the first 3. So we have 25 over 24, 25 over 7, and 7 over 24. In this problem, we're also trying to get the 6 trig functions of angle A. So what we need to do is we need to once again do the Pythagorean theorem to get the third side. Now when we do this, we get 117. And when I take the square root of 117, I need to break this down. So when I break this down, it's going to be 3 times 39 and 3 times 13, which means this is 3 square roots of 13. So when I do this, I once again have to mark my hypotenuse, my opposite, and my adjacent. So the sine of angle A is 6 over 3 square roots of 13, which is actually 2 over the square root of 13. And I don't think we have to worry about rationalizing the denominator for these particular problems. The cosine turned out to be 9 over the 3 square roots of 13, adjacent over hypotenuse, and 9 divided by 3 is 3. And for the tangent, we had 6 over 9, which is equal to 2/3. Now we need the other 3, so we need the cosecant, the secant, and the cotangent, which were just the flips. So I really should call these angle A. And so we got the square root of 13 over 2, the square root of 13 over 3, and 3 over 2. Alright, so we're given the cosecant of theta, but I don't really like the cosecant of theta. I really like the sine of theta much better. So when I do this, we did this in the first quadrant, and the opposite over the adjacent was 4 over 5. So I need to do the Pythagorean theorem to figure out what the missing side is if you don't know about the triple, or if it doesn't happen to be a triple on the final. And so when I subtract the 16, a squared is equal to 9, so a is equal to 3. And so the opposite over the adjacent turns out to be 4 over 3. For problem number 5, they ask you for what is the tangent of negative 180. And so you're just going to put that in your calculator, and as long as you're in degree, you'll find the answer to be 0. Alright, the next problem asks for when the cosine is equal to 0 in the first unit circle. So when I do the inverse cosine of 0 on my calculator, it tells me that the answer is 90. Now, of course, the cosine being equal to 0 at 90 means that this point over here is at 0, 1 because the x value is 0. But if I go down, this point is also at 0, negative 1, so I need to include that angle, which is 270. Now for part B, it asks for what is the secant whose cosine is 1/2. Because these two things are reciprocals, it's very easy for us to come up with the answer to be the reciprocal of 1/2, which is 2. I'm going to end this first video here and do the second half on the next video for chapter number 4.